Hello. So my name is Neil Perry, and today I want to talk about biomimicry, or biomedics, or biomedics, not medics, mechanics. And that basically is the imitation of model systems and elements of nature for the purpose of advancing human life. To engineers, to engineer means to design and build. The definition of these two words run parallel to each other in the sense of that scientists and engineers are coming together to replicate nature. During this talk, I will discuss what scientists and engineers are up to in the field of biomimicry and show a first-hand account of biomimicry itself. Thank you.
Okay, so first I want to talk about an experiment in biomimicry that a lot of people know about. Alright, so it basically Alright, so basically I want to talk about an experiment that a lot of people that's happening because of biomimicry. So basically it has to involve chromatophores, which are pigment cells that contain reflecting organelles, and these cells are controlled by muscles that expand and contrast. So I don't really know how to explain it, but I do. It's like little balls. I guess like they're together, and then like when something happens, just like it's bigger, smaller. Yeah. All right, so that happens, and basically these cells are found in cephalopod. I don't know how to pronounce it. Cephalopods, basically octopi, squid, and cuttlefish. I'm pretty sure some of these cells are also found in reptiles like chameleons. But anyway, what scientists and engineers are doing, they're trying to understand how photosynthesis works through chromatophores, because chromatophores contain things called photons, and photons are organisms that carry out photons to basically photons capture energy, and that is what is in chromatophores. So basically scientists and engineers are using a GPU, which is a big computer, and they're trying to replicate the process in which these photons interact with each other in order to understand how photosynthesis works. So basically, they are digitally making a synthetic cell. And I think that is really cool, because we are copying nature's energy source, and we're about to be able to understand it, and that is really cool. So the reason why they're using this computer to replicate these photons in the chromatophore cells is because scientists don't really know how these photons interact with each other, and they're going to use this computer to simulate different reactions and hopefully understand how photosynthesis works and be able to reproduce it in biomimicry. And that's a perfect example of biomimicry. Okay, so next I will talk about swimsuits. Alright, so for the next thing I'm going to show you how scientists replicated dermal denticles in shark skin in order to put it into swimsuits. And those are the things that you saw in the 2008 Olympics, some of them. Michael Phelps wore them, and I actually have one. So I will show you what the difference between that and a regular suit is, and it's really amazing. Uh, so basically, why um, these things are different is because these overlapping scales, they run down like they're grooves, and they run down, and they just like it's like that, and they just allow water just to like not. They're basically like hydrophobic teeth, I guess, because well, not teeth because it's cartilage, but um, just hydrophobic skin cells, which is really cool. So I'll show you that.
Okay, this is the first suit I'm going to show you. It's made of regular fabric. It's kind of beat up. It's a Don suit. It's one full suit. Alright. Okay, I'm just going to pour water on it. Basically show you that it's not a good example. Oh, it's steaming. It's pretty cold out here. Anyway, this is a suit. It doesn't really, it's very absorbent to water. Yeah. Okay. Okay. This next suit, it should hold water a little bit better, but it's not a shark skin suit. It's called an aqua blade. It's basically almost, it's just, I don't know. I think it gives you a little bit more buoyancy, and it doesn't. Ooh, see that? Yeah. And something cool about it is, it's pretty cool. Alright. Pants falling down. Hello. Alright, so this is a shark skin. Basically, shark skin suit. Basically, it repels water really easily, and water doesn't stick to it. You laughing, Mom? See? You go like this. Just falls off. Which is pretty cool. Oh, my socks. Basically, just very water resistant. You can shake the water off. Okay, I'm done. Hit okay.
All right. Now that you saw that, I just want to say, I just want to wrap it up with saying that engineering and biomimicry go hand in hand, or they can go hand in hand in the future, because right now biomimicry isn't a practice, or it is practice, but it's not a recognized thing, kind of. Like, you can't get your degree in it, and I think that the world can benefit from copying nature by that example of photosynthesis, or just understanding how the chromatophore cells work and being able to create color changing cells. Um, there's other examples, like some scientists found out that if you shape a what are those things that go around and around? You know, the solar blade. No, it's the solar power things. If you shape it like a whale's fin, it's a lot more efficient, and it creates a lot more energy for less energy put out. So, I guess, yeah.